Delhi doesn't have an air pollution problem. Well, calling it pollution is like calling tsunami just water. Jokes apart, today I wanted to talk about the air quality crisis in Delhi, and we are going to be understanding it using science. This video is divided into 4 parts. In the first part, we will discuss what is safe air. In the second part, we will understand how pollutants are formed. In third part, we will explore the primary reasons behind Delhi's air crisis. And fourth, we will explore a few technological solutions that have to be put in place that can solve this, not just for Delhi but other Indian cities as well. To understand how bad Delhi's air is, we first need to know what safe looks like. There are 2 standards we need to talk about. The World Health Organization says that in a 24-hour period, the safe limit for PM 2.5, that is fine particulate matter, the really dangerous stuff, is 15 micrograms per cubic meter. India's National Ambient Air Quality Standards says that in the same 24-hour period, this limit is 60, and that is the legal limit. Basically, that's 4 times higher than the recommendations provided by the World Health Organization. Now, here's the thing. On November 12, 2025, Delhi's actual PM 2.5 level was 452. Let me say this again. Who says 15 is the safe limit? India says 60 is the safe limit. And in Delhi, PM 2.5 levels were 452. Let them sink in. That's 32 times higher than 2's limit and 8 times higher than India's own legal standard. This gap between standards isn't just technical, it has consequences. A Lancet study found that for every 10 microgram increase in PM 2.5, the daily deaths increases by 1.4%. And across 10 major Indian cities, 33,000 deaths per year are attributed to pollution levels above WHO limits. So welcome to part 2. Now, just like a dish has a recipe, so does pollution. So in order for us to understand pollution, we need to first understand the sources of it. Now, according to SAFAR's 2018 study, here are the major findings. Transport contributes to 41% of all the pollution. Resuspended dust contributes to 21.5%. Industry contributes to 18.6%. Power plant contributes to 4.9%. And biofuel contributes to 3%. But here's the problem. This study is very old, and this is one of the things that I will talk about later on when we discuss how to fix pollution. But wait, there is more. In the newspaper, you probably have heard that all of this is occurring because of stubble burning. What is that all about? In order to understand, we need to be very clear about one thing. Delhi's pollution is attributed to 2 reasons. The first reason is that a chronic year-round baseline of pollution from its own sources, mainly transport and dust. Now remember this, just because of transport and dust, the air quality is already bad. Anything in addition to this is going to make the problem worse. So all of us need to focus on this. We need to solve for pollution arising out of transport and construction dust. Problem 2, an acute seasonal injection from stubble burning, where farmers in Punjab and Haryana burn crop residue in October and November. It can contribute anywhere from 2 to 3% all the way up to 22 to 30%. And studies have shown that this can go as high as 48%. Now, the biggest problem is that all of these numbers are based on 1 or 2 studies that were done a while back. And it is very, very important for us to understand that in order to control pollution, we need to start measuring pollution accurately. Also, we need to not focus about stubble burning because that is the accelerating part of the pollution. Right? It is the second piece. The primary piece, again, is because of transport and construction dust. Remember how I said transport contributes 41%? Well, cars and trucks don't just emit soot, they emit nitrogen oxides and volatile organic compounds. These are like raw ingredients. When these ingredients interact with sunlight, specifically UV radiation, these ingredients cook. NOx and VOCs react in the sunlight to create new pollutants. Primarily, this results in the formation of ozone and something called as peroxyacyl nitrates. Together, these form the brownish haze you see. This is also called as the photochemical smog. This stuff is really bad. Now, here's the interesting part. Pollution because of transportation and dust is applicable for every Indian city. So, why is the effect so prominent in Delhi alone? Well, this boils down to two reasons. If you take pollution and let it disperse, it becomes less dangerous. But Delhi has a unique problem, actually two problems that work together. The first problem is that Delhi is a geographical bowl. Delhi sits in the Indo-Gangetic Plain, a vast, low, bowl-shaped region. To the north, you have the Himalayas, this massive mountain range that blocks air movements. To the southwest, the Aravalli Hills create another barrier. All the emissions from cars, industry, dust, and stubble burning get poured into this geographical bowl with nowhere to escape. The air becomes stagnant. The second problem is purely because of winter physics. Let me explain that. Under normal conditions, the sun heats the ground. The ground heats the air near it. The warm air rises, carrying pollutants up and away. This is called as convection. In winter, especially during calm nights, this entire process flips. The ground loses heat rapidly at night and becomes very cold. The air touching the cold ground also becomes cold, dense and heavy. As a result, what happens is it is not able to move. And here is another problem. A layer of warmer, lighter air sits on top of this cold layer. It is almost like how oil sits on water. This warm layer acts as a lid. The cold, heavy, polluted air at ground level, the air that you are breathing, cannot rise through this warm lid and all vertical mixing stops. This is called a temperature inversion, and it is why Delhi's pollution spikes so dramatically in winter. If you dive deep into this, you will actually come across another problem. The temperature inversion, the overall effect of pollutants getting trapped, actually becomes more prominent with more pollution. So this effect kind of gets worse recursively. So how can this be solved? Well, here's a 10-point action plan which I think can be implemented quite easily. Step number 1 is to implement real-time, high-resolution source apportionment. All this means is you have to figure out what's the source of pollution in a real-time basis. The study that I talked about is several years old and it is not useful today. We need real-time measurements to understand what is the current problem and take actions to solve that. The second solution is to use the best available technology to curb pollution in industries. For example, processes such as flue gas desulfurization must be mandated. These are scrubbers that remove sulfur dioxide from power plant exhaust. This is already mandated for TPPs and must be 100% implemented. Wet electrostatic precipitators. This technology uses electrostatic charges to remove fine particulate matter, aerosols and mists from industry flue gases. Third, Dagos filters. Mandate the replacement of older, less effective multi-cyclone filters with modern Dagos for dust-intensive industries. Third solution, enforce 100% industrial fuel conversion. So here we need to complete the full non-negotiable transition of all industries in the entire NCR region to cleaner fuels, primarily piped natural gas. Step number 4, deploy on-road emissions monitoring for vehicles. Studies show that a small number of super polluting vehicles are responsible for a large portion of emissions. Lab-based tests are often fooled, but remote sensing uses infrared and ultraviolet beams to measure a car's actual exhaust as it drives by. This data can be used to issue fines and fix-it tickets to the worst offenders. This targets the 41% of pollution coming from the transport sector. Step number 5, accelerate the twin transition in transport. Here the idea is to create a two-part policy to aggressively phase out internal combustion engines. So here you have to make sure that EV adoption increases and announce and implement an aggressive timeline for the next generation Bharat Stage 7 emission norms, which will force automakers to invest in engineering that further cuts NOx and PM emissions, aligning India with global standards. Step number 6. Dust accounts for over 21% of PM 2.5. So first is we need to have a mandate in construction sites to have a 3-meter high barricade, a wet suppression system, and a tarpaulin covered vehicle, and a total ban on open air cutting or grinding. Step number 7. Solve stubble burning. Treat crop residue not as waste but as a resource. Use policy and subsidies to fund the engineering and logistical supply chain for an off-site waste management. Step number 8. Eliminate open waste and plastic burning. Implement a strict no-burn policy by investing heavily in comprehensive municipal solid waste management and infrastructure. Step number 9. Shift from a reactive to proactive governance. I don't think this requires any explanation. Step number 10. Create a proactive public health advisory. A lot of people are still not aware about pollutants and how something like a road construction dust can actually cause health issues over the long term. This requires continuous education, and here we should follow the model that Singapore had in place. Alright, hope you learned a thing or two. If you enjoyed this video, consider subscribing, and I'll see you in the next one.